Dear students, welcome back to episode 2 of integration. In this episode, I am going to solve very simple problems so that you will aware how to do integration, how to handle the integration problems. Before proceeding further, I would like to request you that please make your derivative strong enough before watching this video. I will provide the links of all derivatives episode on my channel in the description box. So before integration, please go through them once. Then you come back to this episode. Then you will have better understanding. In this episode, I am going to solve the very simple problems so that you will aware of how to solve the simple problems and what are the different tricks while solving the integration problems. So let's start with first very basic thing, that is the integration of x raised to n with respect to x. So integration of x raised to n is any number, like n is equal to 1, 2, 3, 4, 5, 3 by 2. It is any number. So integration of x raised to n with respect to x equals to x raised to n plus 1 upon n plus 1 plus c. Example, x square with respect to x. Integration of x square with respect to x is nothing but x raised to 2 plus 1 upon 2 plus 1 plus c, that is equals to x cube upon 3 plus c. Or if you say the integration of x raised to 3 by 2 with respect to x. So integration of x raised to 3 by 2 with respect to x, nothing but x raised to 3 by 2 plus 1 upon 3 by 2 plus 1, that is equals to x raised to 5 by 2 upon 5 by 2, that is equals to 2 upon 5 x raised to 5 by 2 plus c. Here is the example number 1, integration of x cube plus x square plus x upon x with respect to x. So what you can do, you can split into the fraction like x cube upon x plus x square upon x plus x upon x with respect to x. After that, this is equivalent to x square plus x plus 1 with respect to x. Integration of x square plus x plus 1 with respect to x. What is the integration of? Now we can write them in the separate part, like integration of x square with respect to x, integration of x with respect to x, integration of 1 with respect to x. After this, the integration of x square, we already learned that integration of x raised to n with respect to x, nothing but x raised to n plus 1 upon n plus 1 plus c. I would like to tell you one more thing here, that integration of nx, integration of n with respect to x is nothing but nx plus 3. Integration of 2 with respect to x is nothing but 2x plus 3. Integration of 3 with respect to x is nothing but 3x plus c. Integration of 100 with respect to x is nothing but 100x plus c. You remember this. Therefore, here integration of x square nothing but x raised to 2 plus 1 upon 2 plus 1, and here is the integration of x. So there is the number 1 here. When it is x is nothing but x raised to 1. X is equals to x raised to 1. Therefore here integration of x is nothing but x raised to 1 plus 1 upon 1 plus 1, and integration of 1 is nothing but x plus c. This is equivalent to x cube by 3 plus x square by 2 plus x plus c. So therefore integration of x cube plus x square plus x upon x with respect to x, nothing but x cube upon 3 plus x square by 2 plus x plus c. This is required answer. Now example 2, integration of x square plus x cube upon root x with respect to x equals to how much? Again it is the same problem. We have to split into the parts, that is x square upon root x, splitting into different fractions, x cube upon root x with respect to x, and the value of root x nothing but x raised to 1 by 2. Therefore, it is x square upon x raised to 1 by 2 plus x cube upon x raised to 1 by 2 with respect to x. This is equivalent to, whenever the integration is given, we write like I is equal to, so I is equal to, here I equals to, here I equals to x raised to 2 minus 1 by 2 plus x raised to 3 minus 1 by 2 with respect to x. So this is equals to I equals to x raised to 4 minus 1 upon 2 plus x raised to 6 minus 1 upon 2 with respect to x. So I equals to x raised to 3 by 2 plus x raised to 5 by 2 with respect to x. Now we can separate them into two parts. So integration of x raised to 3 by 2 with respect to x, integration of x by 2 with respect to x. After this we do the integration separately. Therefore I equals to x raised to 3 by 2 plus 1 upon 3 by 2 plus 1. What I have done here? Integration of x raised to n with respect to x, nothing but x raised to n plus 1 upon n plus 1 plus c. This formula I am applying here. Now x raised to 5 by 2, that is x raised to 5 by 2 plus 1 upon 5 by 2 plus 1. This is equivalent to x raised to 5 by 2 upon 5 by 2 plus x raised to 7 by 2 upon 7 by 2. That is nothing but 2 upon 5 x raised to 5 by 2 plus 2 upon 7 x raised to 7 by 2 plus c. At the end of result we have to write plus c. So this is required solution of the given problem. Example 3, evaluate integration of ax plus b whole raised to n with respect to x. Now this question is not in the standard form. Standard form means the single variable raised to the single number with respect to x, then it is called as a standard form. Whenever the question is not in the standard form, you have to go for the supposition. You have to put ax plus b equals to t, then you have to convert the problem from one variable to another variable. For example, here let ax plus b equals to t. As soon as you put ax plus b equals to t, what will happen? This will become t raised to n. It will become t raised to n. But the dx is also present. We have to convert the dx to dt. How will you convert? So we have the ax plus b equals to t, differentiating both sides with respect to x. So differentiation of ax plus b with respect to x equals to dt by dx. Therefore a derivative of ax is a, derivative of b is 0, equals to dt by dx, implies dx equivalent to dt upon a. So wherever the dx is there, what do? You write down dt upon a, that is dt upon a. Now a is a constant, take it outside. So 1 upon a integration of t raised to n with respect to c. Thus when a problem is not in the standard form, first of all you convert into the standard form, then you do the integration. Now it has been converted into standard form. So 1 upon a integration of t raised to n with respect to t, nothing but t raised to n plus 1 upon n plus 1. So this is equivalent to 1 upon a. What is the t? T nothing but ax plus b. So we'll put back here the value of the t. So ax plus b raised to n plus 1 upon n plus 1 plus c. This way we handle whenever the question is not in the standard form. Let us take one example on the basis of this formula. Example 4. Evaluate integration of 3x plus 5 whole raised to 7 with respect to x equals to how much? Now step number 1, it is not in the standard form. So first of all convert to the standard form. So let 3x plus 5 equals to t. You see, if we put sometime here, we put here t, we put here k, we put here u. Every different teacher is making different supposition. Here I am putting t, here your teacher might be putting u, or your teacher might be putting k or something else. So let 3x plus 5 equals to t, then differentiating with respect to x. So differentiation of 3x plus 5 with respect to x equals to dt by dx. Therefore it is 3 equals to dt by dx. Therefore dx equals to dt by 3. So first step is over. Now I equals to, what is I equals to? In place of 3x plus 5 we can put t here, so it is a t raised to 7, and in place of dx we can write dt upon 3. So I have written the dt upon 3. 1 upon 3 is a constant taking outside, so it is a t raised to 7 with respect to t. Integration of t raised to 7 with respect to t, that is 1 by 3, and integration of t raised to 7 nothing but 7 plus 1 upon 7 plus 1 and plus c, that is equals to 1 upon 3 t raised to 8 upon 8, that is nothing but t raised to 8 upon 24. And after that, what is t value? T value nothing but 3x plus 5. Therefore I equals to 3x plus 5 whole raised to 8 upon 24 plus c. This is required solution. Next question. Evaluate integration of 1 upon 2x 6x plus 2 whole cube with respect to x. Now I equals to integration of 1 upon 6x plus 2 whole raised to 3 with respect to x. We know that 1 upon ax plus b whole raised to n can be written as ax plus b whole raised to minus n. Therefore I equals to integration of 6x plus 2 whole raised to minus 3 with respect to x. Now this problem has been converted as if the previous problem, only here upon is there, so we have removed the upon by doing algebraic operation. So I equals to 6x plus 2 whole raised to minus 3. Let 6x plus 2 equals to I. Sorry, 6x plus 2 equals to t. Now differentiating with respect to x. Therefore differentiation of 6x plus 2 with respect to x equals to dt by dx. Therefore derivative of 6x is 6, derivative of 2 is 0, equals to dt by dx. Therefore dx equivalent equals to dt upon 6. Therefore I equals to integration of in place of 6x plus 2 we can write t, so it is a t raised to minus 3, and in place of the dx you can write dt by 6. So 1 upon 6 outside, integration of t raised to minus 3 with respect to t equals to 1 upon 6, integration of t raised to minus 3 nothing but minus 3 plus 1 upon minus 3 plus 1, that is equals to 1 upon 6 t raised to minus 2 upon minus 2. So I equals to t raised to minus 2 upon minus 12. So that is equals to minus 1 upon 12 t square. Now putting for t nothing but 6x plus 2. So I equals to minus 1 upon 6x plus 2 square, and here is the 12. So minus 1 upon 12 into 6x plus 2 whole square. This is required solution. Suppose we are given integration of 1 upon root of 6x plus 5 with respect to x equals to how much? Here is the root is given. How will you handle here? So I equals to, the in place of the root you can write its value. So root 6x plus 5 nothing but 6x plus 5 whole raised to 1 by 2 with respect to x. This is nothing but 6x plus 5 whole raised to minus 1 by 2 with respect to x. Now let 6x plus 5 equals to t, derivative of 6x plus 5 with respect to x equals to dt by dx. Therefore dx equivalent to dt by 6. After that I equals to integration of t raised to minus 1 by 2 and dx equivalent to dt by 6, 1 by 6 outside, integration of t raised to minus 1 by 2 with respect to t, 1 upon 6, integration of t raised to minus 1 by 2 is nothing but t raised to minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. This is equivalent to 1 upon 6 and t raised to 1 by 2 upon 1 by 2. This is equivalent to 2 upon 6 into t raised to 1 by 2. This can be written as a root t. So that is root t here. So cancellation, 2 ones are 3s are. So 1 by 3 root t, but plus c. But what is the t? T nothing but 6x plus 5. Therefore root 6x plus 5 upon 3 plus c. This is required solution of given integration problem. Let us move to the next example. Example 7. Evaluate integration of 2x plus 3 raised to 4 plus 1 upon 5x plus 3 cube with respect to x. So first of all let I equals to one upon 5x plus 6 whole raised to 3 with respect to x. Bracket is important. Now separating them. So integration of 2x plus 3. Here I would like to tell you integration of f of x plus g of x with respect to x. Suppose two functions are there, then you can write integration of f of x with respect to x plus integration of g of x with respect to x. So here also doing the same thing, integration of 2x plus 3 raised to 4 with respect to x plus integration of 1 upon 5x plus 6 whole raised to 3 with respect to x. So I equals to integration of 2x plus 3 whole raised to 4 with respect to x plus integration of 5x plus 6 whole raised to minus 3 with respect to x. And after this, here we can do like earlier case, integration of ax plus b whole raised to n with respect to x, and here we can do ax plus b whole raised to minus n with respect to x. By using that formula you can do. So this remaining part of this problem is left to you as an exercise. Next example, integration of 3x square plus 2 whole square with respect to x. What you do here, you cannot put 3x square plus 2 equals to t, because after putting t here we have to do derivative. After derivative we will get the 6x here. So a variable is also coming, constant is not coming. Therefore we cannot put here t, 3x square plus 2 equals to t. If x is somewhere is present in the given question, then you go for the substitution method. But here you cannot standardize the problem because of the one variable is left. So whenever a variable is left, you cannot standardize the problem. For that you need to expand the function, that's all. Therefore we are opening the bracket, we are applying the formula here, a plus b whole square equals to a square plus 2ab plus b square. We are going to apply this formula. Therefore I is equals to 9x raised to 4 plus 6 into 2x square plus 4 with respect to x, that is nothing but integration of 9x4 plus 12x square plus 4 with respect to x. So integration of 9x4 with respect to x plus integration of 12x square with respect to x plus integration of 4 with respect to x. This is, here is a constant, take it outside. So 9 into integration of x raised to 4 with respect to x. Here is a constant, take it out of the operation. So 12 into x square with respect to x. Here also constant 4 integration of 1 with respect to x. So that is equals to 9 into x raised to 4 plus 1 upon 4 plus 1 plus 12 into x raised to 2 plus 1 upon 2 plus 1 plus 4x plus c. So this is equivalent to, therefore I equivalent to 9 into x raised to 5 upon 5 plus 12 into x cube upon 3 plus 4x plus c. So that is equals to 9 upon 5 x raised to 5 plus 12, 3 ones are 4s are, if cutting possible you can cut them. So we got here the 4x cube plus 4x plus c. This is required answer. Before taking next example, I would like to tell you that integration of 1 upon x with respect to x, whenever the integration of 1 upon x is there, don't write like this. Don't write like this. This is wrong. This is wrong. This is totally wrong. Don't do like this. This is not allowed. So integration of 1 upon x with respect to x is nothing but log of x to the base e plus c. Remember that integration of 1 upon x with respect to x, nothing but log x to the base e plus c. So now we will do one more problem in which 1 upon x is also coming. Example 9. Evaluate integration of x cube plus x square plus x raised to 4 upon x raised to 5 with respect to x. So I equals to integration x cube plus x square plus x raised to 4 upon x raised to 5 with respect to x, separating. So x cube upon x raised to 5 plus x square upon x raised to 5 plus x raised to 4 upon x raised to 5 with respect to x. This is equivalent to 1 upon x square plus 1 upon x cube plus 1 upon x with respect to x. So I equals to integration of x raised to minus 2 with respect to x plus integration of x raised to minus 3 with respect to x plus integration of 1 upon x with respect to x. This is equivalent to x raised to minus 2 plus 1 upon minus 2 plus 1, x raised to minus 3 plus 1 upon minus 3 plus 1 plus log x to the base e. Just now I told you that integration of 1 upon x with respect to x, nothing but log x to the base e. So this is equivalent to x raised to minus 1 upon minus 1 plus x raised to minus 2 upon minus 2 plus log x to the base e. Therefore I equals to minus 1 upon x minus 1 upon 2x square plus log x to the base e plus c. This is required solution. So that's all in this video. In the next video I am going to solve the integration of improper fractions. So till then, wish you good luck. All the best.